30th. 27. We need a different question. Integration. I think we've exhausted integration 2021. I'm going to open up older paper, people. Where is it? It's got something like 2018, 17 maybe. 2017. Let's go 2017. It's alright, Dahlia. Catch you later. Alright, let's pull up these questions. Oh my god, that. Shall I give you a very horribly easy, horrible question to start the day? Oh no, this is doing this thing. Right, just give me a second. It's just playing up at the moment. Ah, look who's decided to join us. Yes, Watson, we hear you, mate. We hear you. All right. This question here, it's actually not too bad. It's just stupidly annoying. Let me just sync up the paper and then we should be good to go. Cranky dog. Sync this notebook. Oi, Watson! Rin, I think you should ask these people. There we go. There we go, people. Yeah, I don't. Well, is it like? I guess so, because I don't know. I just saw this. Like, seriously, this is the most annoying question that you're going to get. I promise you that. This is so easily the most annoying excellence question you might ever get. I know, look, I'm gonna be brutally honest. I just have to highlight one thing, and you guys will be like, oh, that's what's happening. Okay, I'm only gonna do one thing, all right? I'm only gonna do one thing. I want you guys to watch this. That's all I'm gonna do. I think that's enough. That's Is Zoom like a WhatsApp thing? What the hell? Liam, do you not know what Zoom is? Is my hint not come through yet? Yeah, we all lived in Zoom. Guys, let me know if do you still need help, or like I told you, this is going to be the most annoying question ever. Yeah, u of x is equal to x. V dash of x is equal to e of x. That's it. That's your hint. You don't need anything else after that. That's your hint right there. I don't think you need anything else beyond that. Like I told you, you're gonna hate me for this because this is one of the most easiest excellence question you're gonna do. But it's all about understanding the formulas. Because I've seen questions like this come up a couple of times, right? They give you this really horrible equation, and all you have to do is just substitute it in. I know, right? This is such a ridiculously easy question to get for an excellence. Oh, you guys at Google Meet. All right, I'm gonna do this question now. So all it is it basically says integral. I'm not even gonna copy that. I'm just gonna write that as it is. So u of x is equal to x. V dash of x is e to the power of x. So when we have x ex dx, this is equal to u of x, which happens to be x. Now if v dash of x is ex, then we know that v of x is equal to ex. We can put the plus c, which we can't put the plus c, but do we need to put the plus c now? Nah, it doesn't matter. We can add a constant at the end of it, so that's fine. So v of x is equal to e of x minus integral of v of x, which is e of x. U dash of x is equal to 1, so times 1 dx. And what we get is x e to the power of x minus integral of e to the power of x is just e to the power of x plus c. And that's it. And we're trying to find it between 1 and 0. So if we're trying to find it between 1 and 0, we're looking for x ex minus ex. Plus c doesn't really matter because we're finding definite integrals. So this is going to be between 1 and 0. Whatever that is. So we got e minus e, which equals to 0, minus x is actually equal to 0. So that's 0 minus 1. So we get an answer of positive 1. That's it. That is a ridiculously annoying excellence question. Reciprocal of E, that's ln. Of course, Ethan, all of my streams from like 2017 are still there for you to go back and watch it at your own leisure. All right, let's do I can't believe that's an excellent question. Ooh, oh, this is solid. Another brutal. How mean do we want the next question to be? Jack, I just matched the equations. That's all I did, because the equation looked like this. This was the equation, integral of x e of x dx. Now the reason why I went with, I mean, you could try doing it the other way, but I think you're gonna get like, that's gonna be a little bit more complex. All right, you guys asked for this. Well, the reason is I'm picking this question is because I think I'm just going to enjoy doing this question. But all right, let's see. It's going to pop up shortly. Where did x go? X is equal to 0, because remember we have to substitute x as well. I'll chuck in the line numbers. 1, 2, 3, 4, 5, 6, 7. How did you get rid of 1 of the x to the power of e of x? Next Fent, I'm not sure I understand your question. Can you tell me which line? By the way, guys, next question is up on the bottom of the screen. It is a proof question, right? And I've always told you guys this. If you ever see a proof question, drop everything and start working on it, because you literally got 10, 12 minutes to get a free excellence 8-pointer. Right, so if you remember this, you know how do I do this? So if you were trying to find integral of x squared plus 2 between 3 and 0, you would integrate this to x cubed over 3 plus 2x, and then you know how you do this step here? 3 and 0, that's what I've done in this step after I have integrated. So I integrated it, then I put that with the limits of between 1 and 0. Yes, Liam, I think you are taking this class next year, and this is the excellence questions. So what is with the second question? It's all I can say. Oh, okay. Next font. I think I understand what's happening with you. I copied this. Imagine it like this. Give me a second. Let me just put this. Allow. Oh, that was interesting. Okay, I think I know what happened here. So this line here is basically just that part written there. Now, when I integrated it, this, how do I explain this? So, you know, in this part here, I actually had to do integration. When you integrate the red line, you automatically get the light blue line. So I've integrated the red line. That's the formula. So when I integrate the red line here, I get the blue line. Normally, you would actually do this thing here where you'd go, okay, so I've got this, then I would integrate it to get this part here. But in this question, the integrated part is already given to you. Rin, those are just line numbers just to help me figure out where you're having problems. For Neil, I don't know which question you're talking. Are you talking about the second question or the first question? Yep. You're on the right track. Keep going, Rin. Keep going. Okay, I'm gonna start doing the second question now. So our first step is that they actually tell you x equals to sine u. All right, if that's the case, then I'm going to do this first step. So if x is equal to sine u, then dx du equals to cos u, and then dx is equal to cos u du. Hopefully, everybody's okay with that part. Now, the second part is this. We are doing 4 multiplied by between 1 and 0 square root of 1 minus sine squared u dx is now changed to cos u du. So remember that dx is equal to cos u du, and I would have had I might actually do this one extra step here. Hold on, people. So this was the original equation between 410 square root of 1 minus x squared dx, and because dx is equal to cos u du, I've done that. Now x is equal to sine u, so I'm going to replace the x with sine u. Now guys, remember the question is asking prove that it equals to pi. So Blake, finish the question off, man. Come on, dude, you're killing me. You got to get that E8. Now there's one more thing that you guys need to do, which we kind of have to do this in the substitution. So because it's we've changed x into u, these 1 and 0, we can't actually use 1 and 0 anymore because we are now working with u. If you're working with u, if x is equal to 0, then u is going to equal to 0, because if you do u is equal to inverse sine of 0, you actually get x. And if x is equal to 1, then u is equal to inverse sine of 1, and that's going to give you 90 degrees or pi over 2. So we're going to change the limits to pi over 2 and 0. All right, now it doesn't matter because like you could potentially work with x's, but then that's just going to create like too much hassle for you later on. So let's leave it like this. Then our next step, 4 pi over 2, 0, 1 minus sine squared u. Now this is a trig rule. I need to go and find the trig formula sheet. And the one we're going to use is right here. Where did it go? Where did it go? This one. Cos squared plus sine squared theta equals to 1. So 1 minus sine squared theta is equal to cos squared theta. So that means we're going to get square root of cos squared u cos u du. Well, the reason why we do inverse is because remember, x is equal to sine u. We have x is equal to 0 equals to sine u. So u is equal to inverse of 0. And when x equals to 1, which equals to sine u, then u is equal to sine inverse of 1. See you, Alfina. Now what we do is we take square root of cos squared u, which is going to be just cos u times cos u du. Now that's equal to pi over 2, 0, 4. This becomes cos squared u du. Now if you remember, we can't actually integrate cos squared u. So what we have to do is we have to use a double angle for that, which would be 1 minus, cos squared u. Where are we going to use cos squared u? We're going to use this one. I'll just write that down. So that's one of them. So we're going to use that. I've written the formula down here so you guys can have a look at it. So I want to have cos squared u by itself. So I'm going to get rid of the a here and replace it with u. And again, I've got to do this separately, right? So let me just put that all in black so that this is that extra bit of work that we have to do. So then I've got cos 2u plus 1 equals 2 cos squared u, and then cos squared u equals cos 2u plus 1 divided by 2. So when I integrate this, I'm going to go between 4 pi over 2, 0, cos 2u plus 1 divided by 2 du. Then I'm going to take the 2 out, so this will become 4 over 2 pi over 2, 0, cos 2u plus 1 du, which means I'm going to get 2 integral of pi over 2, 0, cos 2u plus 1 du. So far so good. What can I do next? I think I'm ready to integrate it finally. So I'm going to get 2 times cos 2u integrates to sine 2u divided by 2 plus u, and that's between pi over 2 and 0. So then I have 2 times sine 2 times pi over 2 divided by 2 plus pi over 2 minus, what am I going to get? sine of 2 times 0 divided by 2 plus 0. So 2 times sine of pi is 0, plus pi over 2, minus sine of 0 is 0. That's all just 0. And I get 2 times pi over 2, and I get pi as my final answer. Questions, people? Where do we get the 4 over 2? I actually moved the 2 from here to outside because it's a coefficient. Yeah, you can do that for, as long as it's a constant, you can actually take it out of the integral, but it can't be x. If you just use the calc from the bit with a square, are you talking about the calculator, Ethan? But because we have to prove it, Ethan, I think it would be a good idea to do it from maybe step 18. So from step 18, you can skip step 19 and 20 and go straight to 21. 6 to 7, Lucas. All I did was, so remember, x is equal to sine u. Now our two limits for x is 0 and then x is equal to 1. What we need to do is we can't use x in those limits anymore. So if you notice in line 5, I've actually changed it to pi over 2 and 0. That's because when x equals to 0, I'm going to get 0 is equal to sine u. Rearrange it. U is equal to inverse sine of 0, which equals to 0. Then when x is equal to 1, I'm going to get 1 is equal to sine u. And then I'm going to get u is equal to inverse sine of 1, which equals to pi over 2, or 90 degrees. That's what's happening in part 6 and 7, Lucas. Yeah, Noah's, I think if you're going to use calcs, that's fine. Like you can use it from like step, I would say write down step 18, because step 18 just gives the marker that you actually know what you're doing. Awesome. Any other questions, people? Otherwise, we are done for today. Five to eight. 5 to 8 is using the trig rules, because we can't actually do 5 to 8. Oh, that's 5 to 8. All I did was the x and I just changed the pi over 2 there, Noah's. Yes, Tate, this would be a E8 question because it's a full proof question. All right. Nah, J. Crow, I have to actually get back to school now, because I need to do something for my kid. So, sorry, that takes priority. No worries, Sienna. I still haven't posted anything. The step. Yeah, Danielle, the 3 kids started today. They didn't get lost, so that was good. And then I was working on next year's timetable for our school, so... No, this is not bedtime for me, Ren. I just get started now. I think my week has been a bit terrible. Well, it's not too bad. think you can see the green circle. So the green circle is my work and the gray circle is my sleep. So work is at 24 hours for this week. Sleep is at 19 hours for this week. It is called Simple Time Tracker, Ethan. So I've set it up on my, like they're all like little widgets on my, so how do I see this? So you might see the green one there. So that's like how long I've been working on Infinity Plus One. And then I have my school, my store, my commute. Yes, the toilet gets tagged in there as well. No, I get good sleep. Like last week, I slept for 51 hours in the whole week, and I worked for 51 hours. Ethan, you got to manually tag it. So, because my phone's with me all the time, every time I switch over, I just swap it automatically, and I just log my details. This week is terrible, Sienna. This week I'm only averaging 6 hours. It's been really bad. But I'll usually catch up because I usually come home and sleep for like half an hour, 1 hour sometimes just to catch up, and then I'll be like good to go. Yeah, 51, like there you go. 7.27s is not bad. This week is terrible. Like I think this week I'm averaging 6. But anyway, folks, take care. I will catch up with you guys tomorrow. I'm hoping to catch up on my sleep on Friday, which I will. Of course, why not? But let's get through 2024 first. No worries. You're welcome, Lucas. We'll do complex numbers tomorrow, and I'll see if I can find a horrible question for you guys. I think today's 2 questions were quite good. One was an easy, annoyingly horrible question, but the second one was just a lot of work. No worries. You're welcome, Blake. All right, catch you guys. I'll see you tomorrow. Bye.